Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 12. We just happen to be here today because the problem solved quick enough. I had like 40 minutes or maybe an hour of time, and uh, it didn't take that long to solve. So I thought, oh, okay, well, I've solved it. Maybe I'll just make a video today. Don't have to worry about it till tomorrow's video. So anyway, that's what happened. It turned out to not be too hard of a problem. I imagine there's a lot of optimizations to make. Right now, I've got it really slow. So, but I thought I'd throw the video out now, and I can do the optimizations in the recap. Anyway, not too hard of a day. So this video probably won't be too long. Let's just get right into it, though. The story is actually sad. Um, it's like you're flying and you notice that there's a bunch of dragon ducks, and there's like some knight, but he's like an evil knight. He's like kidnapped all the dragon ducks, and they're sending you SOS signals to try and save you. So you go and you're gonna try and set them free, and you decide to spit out a fireball. And the idea is there's a bunch of barrels of certain sizes, and you're going to spit out the fireball, and it's going to blow up that barrel, and then it will blow up all the barrels next to it that are less than or equal, and it will do that like in a chain reaction all over. so that's what part one is. It says, okay, you're going to be given this list right here, and you're going to start at the very top at 0, 0. And you're going to want to blow up all the ones that are next to it that are less than or equal to 9. So 8 and perfect. And then if you look at these two 8s, they can do 5 and 7, but they can't do 9. So now you got 5 and 7. 5 can do 4, 7 can do 7, and then 6, then 6, 6, and 5, 4, then 3, 2, 1. And you can see it kind of makes this little thing. So when you're done, you get this solution right here. That makes sense. The idea is you're basically just continually branching out. And when you throw the bomb. So the reason why I say this day wasn't too hard is this is just a BFS, right? You're doing a breadth first search. You're kind of doing a flood fill type algorithm. So you could either solve this recursively, or you could solve it by keeping track of values. I guess if you did it recursively, it wouldn't be through a BFS. It would be a DFS. But either way will still work, right? The gist of it is keep track of the things you need to do, and then keep track of the list that you've already seen, and then just keep doing things until you've done all that you can do. And that's it. And so I think that's why it's usually called like a BFS for sure. I hope I have that right. Sometimes I get those mixed up, but that's the gist of it. Is you're just gonna flow through the thing, and blow up all the barrels. And like I said, it's just a BFS. So again, it's not that hard. Here's my BFS. I'm gonna be given my input, and I'm gonna be given my frontier, because you actually do this for all three parts. You'll notice it's an array. It's because in part 2 you'll do it in 2 places, and in part 3 you're going to do it, but it's a little bit different. So what do you do? Well, I need to know. I didn't do this with a point this time. I thought, oh, I'll try some of the. I noticed some of the speed solvers, and it actually kind of helped here. Just use tuples, and then they destructure the tuples. And when I first started doing Rust, they didn't do destructuring, but they do now. And so you'll see I do this a lot, and you can do this as well. I've started to do it in some places, but they do it. The Python solvers, especially, you'll see them doing the destructuring. So I thought, okay, I'll follow the restructuring, or the destructuring, I should say. So what do? I just want to get my max row and column, so that when I'm iterating around, I make sure I don't like extend past the grid in either direction. But then I just keep track of everything that I've seen, and I keep track of the work that I have to do. And both of those start with this list right here, right? So this is my quote unquote to do work. And so what do? I just loop through the work and I say, hey, find all the neighbors and only add them if they match. So this is a big if statement, but it's basically just saying, do they match? And again, I think if you were writing this as real code, you'd probably clean this up a little bit, and we'll probably clean it up for the recap so you can see what it looks like in a more cleaned up fashion. But we're just basically saying, hey, is the row within the grid? Is the column within the grid? And is the value that I'm moving to less than or equal to the current value that I have? And if it is, then I'm done, right? It's definitely, what I should say is, if all those things are met so far, it's definitely a candidate for being added. So then I just check, is it new? If I try and add it, is it a new one? And that's what this scene insert does. I think you've seen me do it before. I always get it mixed up, and so it can look kind of confusing if you're not used to it, but we're basically just saying it returns true if it's the first time it's been inserted. It returns false if it's already in there. So this is all basically just to say, am I in bounds? Am I less than or equal to the barrel that I'm moving to, or that I'm coming from? And have I not been seen yet? And if those aren't the case, I just add myself to the list. And then I return the list of seen. And you'll see why I do that later. Is the idea is, at first they just wanted the number, and so I just returned the count. But in later parts, I ended up using the actual hash set, like the unique list of seen, for problem solving. But then for part one, now that I have that algorithm right there, I can just do a BFS on this and it returns len, right? You can see it takes a second to run because P3 takes about a second to process. It's not optimal. I definitely think there's stuff to do. I just don't have time to. I thought I'd get this done. So if you have an optimal way of optimizing these, I'd love to see it. I don't know how much you can optimize part one because you're really just doing a BFS from 0, 0. And maybe there's some optimizations you could do on hashing and your frontier. You might be able to find ways to make it faster. I don't know if it'll be faster to use recursion. Anyway, the point is, part one, BFS, not too hard. Okay. How does it change in part two? So part two, they say, well, now you're thinking, oh, what if I fire 2 fireballs? Then how many do I hit? And what they say is, you're now going to launch a fireball here and here. And you're going to burn through that list, right? Burn through all the items that you hit. My initial thought was, oh, is there going to be an issue where they like meet each other up and cause problems with each other? So I'm like, oh, I don't want to like BFS this one and this one on their own. What if I do a BFS with both of them together to ensure that I have one complete scene list? I don't think it was an issue one way or the other, just because of the way the program works. But again, it's saying, okay, now you're just going to launch 2 fireballs. So what do? Well, I just add 0, 0 and, the end of the grid to my like initial frontier, the thing that like the to-do work that I want to process. I just add that to it, and then I know I'm done, or I know I've covered all of the things, right? The thing that I was worried about is like, what if I traverse this and it like surrounds one number right here that maybe this would never be an issue, but it kind of like it cuts off one, so this one only goes so far, where this one, if I had started this way, this one may have actually collected more than what this one does. I think you could potentially make a thing that would do that. It would just be hard to do, and so I thought, oh well, instead of doing it this twice, I'll just do it once, but I'll allow you to give me 2 values to start the front. And I imagine that's probably the simplest way to, because then they'll all grow together in the same BFS. Like it will, the tentacles will spread in the BFS together. Okay. Okay, so that's part 2. There wasn't much to it. Again, it was pretty easy. Part 3, it actually took me the longest, I think, part, because of the way that I was doing the way that I was solving it. We'll talk about it in a second. But what does part 3 say? You actually can use 3 fireballs, and this time they're not going to tell you the puzzle's not going to tell you where to do it. You're going to have to choose the 3 places that hit the most and do the most damage to the barrels, destroy the most barrels, right? So you can see, like as an example, setting this 6 would do all of these, and then you just want to pick any 2 of these, right, to get the largest. But if you had like a bigger example, you'd say, oh, I want to hit these 3 right here, because like that covers the most part of the grid, the largest part of the grid. So the goal is to find the 3 biggest. And I would like to do some research on this and see if there's like kind of like an algorithm that can join these successfully. There probably is. And that would make this substantially more efficient, because my solution was literally just, here's what I did. I just BFS all the values, LOL. So from every single position, I do a BFS. And now I need to get the 3 largest, right? And so what I do is I say, okay, well, sort them by their length. Again, so notice I'm returning my scene list, right? And then I'm just like adding each one there. So I have like a, I don't know, I think it was like 20,000 total barrels or something like that. 20,000 some odd barrels. And so I'm going to have 20,000 some odd items in this vec. And it's going to be, how many, if I hit this barrel, how many does it do? And so I knew how to get the largest. That was really easy, right? I just pull the largest. And then the part that I struggled with was, okay, well, now how do I get the second largest? At first, I just like returned, the largest -1, the largest -2, like in the array, the bottom 3 values, and that didn't give me the answer. And so I was trying to think like, oh, how do I do this? And part of me was like, while I started working on was, instead of just using a list, I was creating like groupings, and I was doing intersections, and I was saying, oh, if this one covers the other one, so if A is a subset of B, then don't put B in the list, right? But then there were some cases that I wasn't figuring out, and I just didn't spend enough time doing it. And I thought, oh, I have a better way, because what I realized, when I was doing the intersections and stuff like that, I was all like, oh, the largest value is going to take up the most stuff, and then if I remove the largest from the rest, then the second largest one is number 2, and I can just do that. I'm only doing it 3 times, so it's not that hard to do. And so that's how I ended up doing it, right? So I find the largest by sorting, popping it off the end, and then removing all of the values that from the rest of the list that are in largest. Then I sort it again, I pop the second one off, and I do the same thing. Remove the ones that I haven't seen before. And then I do it one last third time, right? Sort it and pop the last one off. This time I don't have to do the retain again. I don't have to remove the values, because we only need the top 3. This is very straightforward iterative. I just do largest, second, and last. And you can see on my computer, it finishes in about a second. So it's not super efficient. I would definitely, and will look for a little bit, like to see some kind of solution where it's trying to merge values. And that might be more optimal, right? Like, think, for example, all the ones, and this may be the way you do it. After you do this on 0, 0, you may just want to go along the edge of these ones, of all of the values in 0, 0, and see if those numbers would contribute more to 0, 0. Like if it would fill up that 0, 0 spot. It's a little hard to describe. Maybe I can show it. This may not be right, but imagine you've done this flood fill at here. You have to. This one's not a good one. Where can I find them? Okay, imagine you've done this flood fill here, and you found this area, right? This also good. Okay, you found this 95968. The question is like if you go to the 8 and you say, "Oh, if I actually can I flood fill this way?" and maybe it will be helpful, right? And you can say, "Oh, can I, flood fill this way?" And you kind of just work your way into doing that. I kind of think that's what you'd have to do is you say, "Can this value extend into this?" Or the other way, the way that I was actually working on was saying like, if I have this set right here and this set right here, are they all encompassed by like this set right here? And if they are, then I shouldn't use these values. And I think that's the reason why I was getting the wrong answer by using the top 3 is because it's possible that like the top 3 like was, for example, this value and then this value and then this value, and that like that's not actually helpful because those values, it might be really huge, right, and it's a large part of the thing, but it doesn't actually solve it, and so that's why it didn't work. I'm thinking there's some sort of like, do they intersect type thing, or maybe what you say is, does one encompass the other, and if it does, then prefer to use the largest of the 3. That might actually be the fastest. I suspect though the thing that took the longest was actually this part of it. In fact, we could time that to see. So what is the thing? Dot. Oh, it is now. Like, why isn't it? Oh. Yeah, so of the like it's like 90% of the time, right? So 90% of the time is doing the BFS all over. So probably the way you want to optimize it is, how do you do this part right here? And probably do these parts at the same time, right? Like I imagine there's some algorithm and I just don't know it. We'll have to look it up. Or please tell me. I'd love to see it. What is the algorithm that allows you to kind of like join these groups together with specific rules? It's probably not even that. Again, I think it's like a growth thing. Like once you've filled up one thing, like try from other positions that aren't seen yet. Maybe, I don't know. Anyway, it definitely would take some more thinking. The problem was is it finished within a second, and so I just like, okay, I'm just gonna solve it how it is. And I don't have a lot of time, so I would love to see how you all solved it. I think that would be cool. You can see I started right about on time, and it only took me about 37. So again, the first part, 10 minutes, was just, okay, I got to read the problem and implement BFS. Not too hard. And then part 2, just a couple minutes because you read it and you're like, oh, it's literally part 1. You have 2 of them. And part 3 took a little bit of time. Again, I think my biggest issue was I had flipped the thing, right? So, or I had tried one algorithm that was not working, and then my second attempt was, oh, what if I just do it this way? It's kind of slower. So yeah, overall I think it was a good day, pretty easy. I think it's one of the ones again where if you've done like BFSs before, it's probably not going to be that hard to solve. The fun part will be the optimization, and I'll do that throughout the coming weeks. I'd love to see how you do it though as well, and then we can come back during the recap and just talk about this is one to optimize. In fact, I had to put that in my notes, my to do right. Yeah, I think it would be really cool to optimize this one. Let's see. Do you have any Redditor? We do have quite a few comments already. Nothing fancy. BFS in part 1 and 2, and a lot in part 3. The only real optimization is starting search from local maximums only plus rayon yielding. Oh, that's a good point. I can ray on this. So I should probably do that right now. So if we just do how do you use par bridge? Would be like this, I think. We're gonna map it to row column BFS. Like, oh, I can never figure out how to do this. Oh, I don't. I think I just par it or. But not. Create a bridge from a sequential iterator to. See. It's like Oh, did it really not do the use? Okay. Oh wow. Okay, so that speeds it up a ton. LOLOL. Okay, so that's a great optimization. Python on 30 seconds, place 443. Well, I wonder why it runs in 32 seconds. Copy scene, deck. Oh, this is a cool thing. So that is, again, it's a BFS. Set best. So he does a scene for each row and column. He calls score, says if there is no best or this lane is better than the original best, best is equal to scene. Okay, so they're keeping a hash set of like the global scene list, and they're all like, oh, if I ever get like the biggest score. No, it's gonna find the biggest one and then add it to the scene set, and then it's gonna find the next biggest one that's not in scene, right? Add it. Okay. I think that's working similar to the way I did it. I'm just doing it in a different way. I did it 2.5 seconds. We'll optimize later. I think this is a thing. A lot of people could probably solve this relatively fast. So you worry about optimize later. Get local max. Was it where you're looking for like nines, then you fill them out? And they're doing. So this is probably the BFS. Yeah, this is, so here's the BFS. Okay. Brute force, that logic custom grid class that is faster hash set for single thread. Okay. Ignite, filter. Okay, this is interesting. instead of using a hash set for your scene list, you just make a copy of the grid and you just like mark them true or false based on when you've seen them, because then you can you do like an O1 check, and it's an O1 insert. So the funny thing about hash sets is they're amateurized to constant time, but they're not always that case, right? There's different ways to implement hash sets. One, for example, like imagine you insert 1 and then you insert 100 and they happen to be inserted in the same position in your hash set. That you have to have some logic of like, okay, well, how do I solve this? How do I do this? And there's a couple ways, like the way you probably learn it in computer science classes. You're like, well, use a list. So that itself is an array or a linked list or whatever, and push it on the list. So then you check them. Another way is to like find the next empty. Anyway, there's a couple ways to do it, but this way, because you know there's like a static set of like which ones you've seen, you haven't, it's probably easier just to like say, hey, I'm going to make a 2D array and then I'm going to mark them as seen and check if they're not seen, because these are literal O1s at the cost of memory the size of the grid. And again, the grid size, there was like 20,000 some odd thing. So that's a cool optimization you could use. Yeah, very cool. Okay, and yeah, so this returns that grid, and so you're just gonna count the ones that are true. So that's why this makes sense, is you're like, oh, count the ones that are found. You ignite, and then you ignite. Okay, so this was the original way that I thought to do it, is like, do I call my BFS twice? I ended up just, I thought, oh, what if there's some overlap? And I don't think there was. Oh, and here's a great way to they solved it right here in a cool way. They said, oh, I'm gonna zip the two together, the two ignites together, and filter by the ones that aren't, that are in A or B, A, B, A, or B. That have been turned on by either A or B. Because this is like a static list of like true or falses, you just say A or B. Yeah. Okay, yeah, that makes sense. That's really cool. Create a list of points to process. Sort unstable by key, grid key. Okay, so the way that this one's working is you're saying, hey, find like the largest values, try them first, keep them, and then remove them from all the other ones that have been seen. Is that right? Create a new set. Remove this from the set, push the set on, and then do more points. Yeah, that's right. So if you've already seen it, you don't do it again, is the way to think about it. Right? Like this has the idea, and this is kind of what I was trying to do, I think, but I was like, oh, I can just sort and do +1, sort and plus, or just try them all and then do this down there. This is an optimization, right? Because you're saying I'm going to add all the points, but I'm going to skip them if they happen to be in my list. It reduces the size of the vector. Not too shabby. Like the thing to note is here, over here in part 2, for example, a relatively large grid can be BFS'd in like microseconds. And so parallelization helped mine a lot, right? Took it down to 2 milliseconds. So that was a cool find. Okay, that's a cool solution. Getting 51st for part 1 and 2 days in a row. Quite pleased to hit 49 today. Nothing clever, just lots of searching. Part 3. Yeah, I imagine that would be Fire Fringe, Try Frontier, Light. So this is like your scene list. and this is your friend. So it is, yeah, we're just doing a BFS. And this is how I would probably normally do this, right? We have a neighbors function. We'll clean it up and it'll look more like this. Ah, this is cool. So they keep they do that. They're essentially doing what I'm doing, right? Is you go through all of the values and it looks like they have some cool things that they reuse, these grids and points and stuff like that. That might be fun. So like the idea is what they're kind of doing what I did, right? Do all the values and find the best one, but keep the ones that the best one, the one that has filled up the most, and iterate through them and filter. So you keep like a static list of ones that you've already seen. I think a lot of people have kind of done it that way, and it seems to solve pretty fast. Okay. Ooh, C. This one built itself for all three parts. Solution part twice, part 3, part 1. Do a brute force check. Finish. Okay. Let's look at the C code. Part 1. Okay, so they chose the recursive approach, right? Which is cool. Yeah. Recursive. Part 2, you probably just do the recursion twice on 2 different places. Yeah. Okay. Okay, looking for the best. You do it 3 times. Okay, it seems like a lot of people are solving it my same way. I'd be interested if there's like a cool algorithm to do this, but otherwise. Runs rather slow, 600 milliseconds. I'm sure this will be optimized. Take a nap first. Okay. Yeah, some people are doing this in the middle of the night, right? I'm very fortunate that, like, at least for everybody codes, it happens early afternoon my time. That's not the same for like Advent of Code, right? I have to stay up in the middle of the night if I want to do it. This is an interesting idea of just using like an array. I think that's cool. You can flatten it out. That's kind of cool. So you flatten it out, and then you can just merge the two by where all of them are over. Okay. Very cool. Yeah, good solutions. I like them. Whoa, whoa. Why is my thing wrong? The heck? Isn't this the only thing I changed? Oh, I know what I did. I need to do a Cartesian product of the two. Okay. That explains the 2 milliseconds. That seemed too crazy. So that sped it up by about like times 3, I guess. Opposed to like times 100. So there's definitely still some optimization to make. And I felt pretty comfortable with like. Well, in the end, we got to the final answer. Okay, lots of great solutions. Again, I would love to see your solutions. Um, and we'll do a recap. And I'm gonna try for the recap to go find like a highlight solution for each of the days, either from your comments or from the Reddit, and like compare it and contrast it, and just like see how I could do mine better, and things like that. So anyway, please send them in. I'd love to see them, or at least let me know that you submitted them on Reddit so I can see them. That would be great. Otherwise, that's a wrap for today. Thank you very much. I had a lot of fun. Bye, everybody.